Let's dive into the magnetic force on an electric charge. Hopefully you remember that the electric force is equal to Q times the electric field. And the electric field is a vector, the force is a vector, and then the direction of the force can be in the same direction as the field or opposite, depending on the value, whether it's positive or negative, of the electric charge. For a magnetic force, it's a little bit different. So I'm going to use the subscript B, FB is equal to, and I'll just leave that as a question mark for now. Based on experiment then, we have realized a few different things about the magnetic force. The first is that the magnetic force is always perpendicular to the velocity of the electric charge. The second is that the magnitude of the magnetic force is proportional to the magnitude of the velocity. And so this symbol alpha means proportional to. And as a quick reminder, the proportional to just means that there's a linear relationship between the magnetic force and the speed, or the magnitude of the velocity, that passes through zero. So this is a key point because that means that when the electric charge has zero velocity, there's zero force, and I can represent it as a dot. I'm just circling it to highlight it. And then the relationship between them being proportional means that there's a straight line between them, if you were to graph this. Now, it turns out that the magnetic force is also always perpendicular to the magnetic field. And the magnitude of the magnetic force is also proportional to the magnitude of the magnetic field. But we're not done yet. It turns out that the magnetic force is also proportional to the strength of the electric charge, Q. And there's one last thing before we put this all together. The strength of the magnetic force is also proportional to sine of theta, where theta is the angle between the magnetic field and the particle's velocity. When we put all of these together, we get one nice equation that wraps this all up nice and clearly, I guess, that the magnetic force, FB, is equal to Q, the electric charge, times V cross B. And this is a vector cross product. And since the cross product V cross B is equal to VB sine theta, we can also write this as F of B, in terms of the magnitude, is equal to Q times V times B times sine of theta, where theta again is the angle between the vector V and vector B. And when we apply it this way, the direction of the magnetic force would be from the right-hand rule. And you can check out the video right below this one showing you examples of how to calculate or how to use the right-hand rule.